So essentially, this is a beginner's guide of how to use Python featuring NYC Open Data. Okay, next slide. The aim of this presentation is to walk you through my project, and my physical project is located on my GitHub account. So these slides are just providing you all with the background, context, and the inspiration of this project. But once we're finished with these slides, we'll be transferring over and we'll be viewing some code on my GitHub account. Okay, and this presentation, these opinions, these anything else are just mine alone and do not are not the views of my employer. Okay, I put this in the Eventbrite page, but this is not a workshop, and we won't be live coding. I did receive a few questions about installing things. Will we be doing some interactive workflows? And the answer is no. I have a project that I've produced. It's all baked that we will be viewing on my GitHub account, but today's session won't be a workshop. One of my colleagues who's also presenting at this conference, Katie Brady, she will be presenting a Python workshop. So if you want the more like hands-on Python interactive workshop, live coding scenarios, I encourage you to please check out her event. But this is just a lecture, talk, inspiration for this project, etc. So what do folks have to know for this project? Okay, I assume the audience understands basic Python or other programming languages, be it R, SQL, Stata, MATLAB, Julia. I'm assuming that the audience has taken a few Python courses and understands basic programming concepts. I also assume that there's basic knowledge of data analysis and basics of Jupyter notebooks, which we can get into, but it's where I write the code. Okay. However, those new to Python, of course, you're welcome. If you just want to feel inspired or you're thinking about Python, you're not sure how Python's applied, I encourage you to just sit back and just see all of the things Python can do. So, but the project does assume these 3 bullet points. Okay, a quick point. Please type it in the group chat if my volume is off or if I'm speaking too fast. And one of the moderators will let me know. As Chidi said, please mute. There will be designated time for questions, comments, concerns, but I think it would run smoothly if everybody mutes. Participation for questions, please use the group chat feature. If at the end of this talk, we can unmute ourselves. If speaking, please announce yourself, name, and yeah, that's about it. Okay. I've also posted these slides. I believe in open source. I believe access to everything. So I've posted these slides on my GitHub account. So if you want to take a screenshot of this, or I think somebody will probably post this in the group chat. You can walk with me through these slides if you'd like. So this presentation has 4 main aspects. I'll touch upon the background and the context of this project, what inspired me, why did I produce this project, and how is it useful. I will then discuss the project. What is this beginner guide? How do we add more color to that? I will also be providing advice to beginners with Python. I know that unfortunately, there's, I think, just a few slides about this topic, but I wish I could talk for hours about a roadmap of advice that I wish somebody told me when I was first programming. So yes, and then at the end of this, we will preview the project on my GitHub account. So if just reiterating, this is not this project or my project, the project is on my GitHub account. So I did have a question before about, will we see the project here? And the answer is no, the project is on my GitHub. This talk just provides a bit more context about it. So we're going to start out with the background and the context of this project. Okay, I created this beginner series because one can learn Python at university or college. One can learn Python at the workplace or through coworkers, and one can self-study, probably the method that I prefer. So one can learn Python at various contexts. One can learn basic print statements and expressions, data types, strings, integers, floats, booleans, etc. One can learn functions, methods, and one can learn loops, if-else statements, etc. But there seems to be a disconnect between learning and applying Python for your own projects. And I can speak for myself. I felt this way, but speaking with colleagues and classmates, the Python courses out there, they really didn't focus on applying those skills. I know I took a quick course on Coursera, and the first few weeks were extracting elements from a list. And although that's very, very useful, it is sometimes friction to beginners of seeing how this beautiful language is applied. And then this is how I started out. I kind of provided an example beforehand, but I took numerous courses online. My favorite platform is Coursera, but I took Python and basic programming courses on edX, on Udemy, Udacity, and various other platforms. I attended tech meetups. New York City has a lot of great organizations doing their best. I met a lot of great people, and I also bought a few books. I'm not sure if everybody's familiar with the O'Reilly books that have animals on them. They're pretty famous in the tech world. However, with those bullet points and others as well, I was unclear about how to apply Python to actual projects. And I can't help but think maybe it was me. Maybe it was how I was learning. I'm not a proficient learner. And I think programming in itself, if you've never programmed before, there's a lot of friction. And I was still unclear about how to apply Python to real-world projects. And then everything changed after that. I felt like I needed a more structured program. I received a scholarship to attend a advanced certificate program at NYU in urban science and informatics. I think I have a few classmates here, by the way, which is awesome. And that's when I enrolled in Professor Federica Bianco's Principles of Urban Informatics class. We all called it PUI, and it was life-changing for me. It really affected everything after that. Professor Bianco is a big inspiration to me, probably one of my biggest mentors. Some of those people that you can look back at specific events and say, this person changed the whole trajectory of my career. I think it was her. It was a huge inspiration on me. So what did she teach and what did she provide in the PY class? She provided hands-on exercises. So typically we would discuss a concept, and then the exercises and the homeworks would be directly correlated with those lectures. We would discuss a typical data analysis workflow. So that was one of my biggest qualms with a general Python course, that it didn't really, a lot of things were scattered to me, and everything we did in her class was sequential. How do you produce something? What's a typical workflow? She also stressed reproducible work and open source teachings. So all of the homeworks, all of the graded homeworks were online. She would help us out with the code, with the best process of that code, and all of our past homeworks were online. So it was a really good learning experience for me to kind of go back to those solutions and identify the proper way of accomplishing a task. And this is probably a big one. We focused on the Python library called Pandas. If you're not familiar with Pandas, it is the essential data wrangling package in Python. It's, I would say most data science projects use Pandas at some point. It's an open source library. It's really closed the gap of difficult Python syntax, and it's packaged functions and methods in a more readable way. That's just my opinion. But I think instead of focusing on too much Python and creating your own functions and writing these big functions that are multi-line code, we started off with Pandas. So I think we had one course of Python. We assigned homework, but I think right after that, I think second week, we just focused on pandas. And as I said, this course changed my whole life about my love for Python, how I apply Python, and how I try to teach beginners Python, and how do we, I should say, apply Python to data analysis projects. Should I stop there and take basic questions? And Nathan Chitty, were there any things that I could speak more of or go more in depth?
I think that was great, Mark. I just want to remind everyone, please, we encourage questions. So just if you have a question, post them in the chat, and we will curate those and get them to Mark. But yeah, so thanks so much, everyone. I think we're good on questions at the moment.
Perfect. Yeah, that's a great point. If you're thinking of something, or if I haven't explained something, I think chances are there's other folks that have the same exact question. So yes, we encourage you to post in that group chat. So that's how this project was born. As I said, this beginner's guide featuring NYC Open Data using Python. It's on my GitHub page. Here's a screenshot from here. I should have put this someplace, but essentially I used Professor Bianco's homeworks. I added to them. I reshaped some of those concepts, and I packaged it to my own project. So the way that I feel like beginners would learn the best. But this beginner guide is really inspired by, I would say, Federica Bianco's course, as well as various things that I've seen on the web. It was a long journey. So my first commit is a Git phrase. It was the first time that I guess saved changes, was beginning of February of last year. So I've been iterating this. I've been probably for the past year now focusing on how I build out this project and the best ways that I can present this material for beginners. However, full disclaimer, I started my first file was, I think, the end of 2019. I started it, I got sidetracked, I didn't like how it was, and I deleted that whole project. But it's been a long journey, and I've been enhancing this on the weekends, in my free time, this beginner guide. So what will one learn from this project? If you get anything today, please remember these 4 bullet points. And I selected these 4 bullet points because, in my opinion, this is the typical process of a real hands-on project. Part 1, reading and writing data. So reading is loading data, writing is exporting data. Even at this stage, if beginners, I had a difficult time reading in data. I know I often share this story with my colleague. She was just starting out with Python, and we're close colleagues at this point. But I remember that she asked, how do you read in data? How does Python read data? And it's easy for folks that have been programming often and a lot to think of this question as a very basic concept. But when you're a beginner, any type of friction, any type of what's the best way to read data, load data, export data, which package should we use? Should we use the pandas library? Should we use CSV reader? The file is in JSON format. There's a lot of things that can go wrong. And if you all have used CSVs, it's not always as intuitive as what you would think, okay? The second part to this is inspect, process, and wrangle data. So once you read in the data, assuming maybe we are looking at a data set that we've never seen before, or the data set has changed, how do we inspect the data? How do we process the data? And potentially, how do we wrangle the data or transform the data in a way that fits our use cases? A quick point about this second bullet, I think this step is often rushed and overlooked. I see a lot of beginners, they read in the data, they inspect it for 1 line of code, and then they start plotting. And that's a big no-no. That's a big red flag. One of my favorite aspects about Python for this work is learning about new data sets, learning about the shape of the data set, learning about questions to answer that I didn't even know I had to ask. So, and we can get to all of these things in the GitHub project. But this second bullet point is essential. And I think this is where beginners kind of rush the process. So let's say that we've read in the data, we've inspected it, we have good data types, floats or floats, integers or integers. We have converted strings that appear to be integers. We've converted them to integers. What's after that? Part 3 is creating data visualizations. I see this step as like conveying insights, conveying thoughts, conveying the data to outside stakeholders, to colleagues, to people that really just want to gather insights from this work. What should folks know about your project? What type of insights have you found, and how can we ask questions to support decision making? And then the final part of this series, part 4, is working with geospatial data. Full disclaimer, this was added quite late to the project. I focus on the first 3 because technically, in my experience, you don't need a geospatial aspect to the project if your data set is not geospatial. However, I think NYC Open Data has a treasure trove of spatial information. My favorite ones are the building footprints, Pluto. I think Pluto stands for Planning and Land Use Tax Lot. But there's a lot of great spatial data sets on NYC Open Data. And I added this tutorial because it could be a big part of your project. Okay, but the first 3 I think that are essential to any data analysis workflow. The fourth one is if you're working with geospatial data. Okay. However, by looking over this project, you will learn indirectly. So it's not a part of that 4-part series, but it can also assist beginners with developing a presence on GitHub to showcase your work. I think that we do all of this great open source work. You want to share your projects, perhaps share your findings. Learning how to use GitHub is very important. A second bullet point is create beautiful notebooks. So in addition to posting Python code, I'm trying to create beautiful notebooks that can assist people possibly not familiar with these topics. The third bullet point is learning Markdown language and creating informative README files. I'm not going to say a lot about this. We can add this. We can go over some of this in my GitHub. Fourth part, please think about your audience. I see a lot of beginners. They do a lot of data science work and they post one big block of code and they expect people to kind of read that code, and it's just Python code. And I guess my advice would be, please think about your audience. This is similar with creating informative README files. Always think about who you're presenting work to. And I think the final bullet point is, we kind of touched upon this earlier, but focusing on reproducible work and open source work. I know that contributing to open source projects and speaking about reproducibility has enhanced my skills immensely and my colleagues' skills. I think, just my opinion, your work enhances if you think about, how does a colleague reproduce your work? How does a stranger reproduce your work? How do you think about package management? How do you think about Python versions? It is really important, and I think contributing to open source projects is a really great thing, and sharing some of your own insights. So what does one need for this project? Obviously Python. All of this work is coded in Python 3. You also need a Jupyter notebook. This is where we write the Python code. I'm accessing notebooks through Anaconda, which is a real awesome data science like package platform that you can access Jupyter notebooks through Anaconda. I have some colleagues that just installed Jupyter notebooks without Anaconda, but personally, I advise folks install Anaconda, and that's how we access notebooks. As I said from the beginning, you should have, or the audience should have, beginner level proficiency with Python. If not Python, possibly R, SQL, but this is really like not a basic Python project. This kind of assumes that you've taken a few Python courses, and the user is familiar with packages such as pandas, NumPy, and plotting libraries such as matplotlib and seaborn. Okay, and because this is an applied project, so we're using Python as a tool for our own data analysis needs. I think maybe basic knowledge of descriptive statistics, summary statistics really helps with understanding this. Okay, Nathan and Chitish, do we have any questions, or was that too fast? Is there anything I can elaborate on?
Hey, Mark.
No, go ahead, Judy.
Okay. Thanks, Mark. Yeah, there are a couple of things that people that chimed in the chat, and I think Tom was able to actually answer his own question, but we always welcome that. Tom wanted to know about the watermark and can explain like what's the purpose of the watermark in terms of adding to your notebook, your Jupyter notebook.
Okay, I can. Geez, that's a great point. I can. We can go through that on my GitHub account, but since we're here, it's about. I think watermark is a package that I found online that prints out your library's versions. So why is that a big deal? You might execute code, or you might have code that you received from your colleague, but you have different Python versions, or you have different seaborn versions. So I think really going back to that whole reproducibility concept of really printing out, these are the versions, giving your audience, providing your audience more information about your ecosystem, your libraries versions, etc. So I can go into that. I know that I can share my screen once we're inside the project, but does that answer the question?
Yeah, I think so. That's good. Another question that was posed was regarding free online sources to teach Python and other programming languages. Two of the ones that were posted by Anne were EDX and Coursera. Are there any other free resources that you would recommend?
Yeah. Well, I would say besides this project, yeah, that's a great question. So I don't get paid for any of these courses. I'm not sponsored by anything. I tend to like Coursera's courses. I think when I was first starting out, one of my favorite Python courses was a course taught by the University of Michigan on Coursera that was really, really valuable with like basic programming concepts. I forget what that course was called, but actually I think I loved the course so much. I shared it with my mom, and I had her like look at it because I was so interested and I was so ecstatic about that course. But I would say that I like Coursera courses. I know that if you want a certificate, it's a paid subscription, but I believe you can audit just about anything for free on Coursera. I think I think that's a great question. It's difficult to answer depending on people's skill set. I think that checking out EDX, checking out YouTube or some of those other online streaming platforms, kind of soak yourself with programming concepts. I will never be against taking Python courses. Like I think the more Python, the better. However, eventually I would start to kind of seek out courses that actually apply some of those skill sets and not just have coursework in like one-off exercises. I hope that answers. And I have a few Python books. As I said, I've been programming for the past 4 years now. I just bought like a basic Python book the other day because the field changes, there's new methods, there's new functions, and there's more proper ways of writing Python code. So it's really like a lifelong journey. But I would start out with Coursera and edX and other platforms.
Thanks, Mark. We continue to encourage the audience to ask questions, and we're very grateful for other audience members providing answers in their own, I guess, websites that have been helpful for them. I think we can continue. I know there was a question regarding downloading the data set. I'm looking into that issue.
Okay.
But we will, we can continue, Mark.
Sure. A quick point about this data set. and we can get into it while I'm analyzing the project, but the building's footprints file, for some reason, I think the agency versions this data set, so it's a broken link. So the building footprints data set is probably outdated. For some reason, the agency versions it probably like weekly. And I think I probably have a previous version. So that's a quick point if you're trying to follow along with the building footprints data set, the link could be outdated, okay? But let's continue. So advice to beginners. Before we go to the project on GitHub and we sort of look at these questions hands-on, look at code, look at files, etc. These are my advice for beginners. So if I had to go back in time and look at what I wish somebody told me when I was first programming, I would probably start with these bullet points. We already talked about Anaconda and writing code in a Jupyter notebook. I haven't really explained these tools too much, but Jupyter notebooks is where we execute the code, and then Anaconda is really just a system that stores package versions, and that's how I access notebooks. Okay, I would say, I think I alluded to this earlier, I will never be against suggesting Python courses, but I think if your goal is to analyze data in a data analysis or a data science way, learning Python for web apps is probably, there's a big disconnect there. I think starting with the library pandas is very, very useful. It's really opened up this whole field with having Python more accessible, having folks not in the computer science field really get their hands on Python. I would suggest starting or finding a course that offers pandas. I think third, reviewing other people's code. I think that I mentioned YouTube or online courses, but I think there's a very popular data science website called Kaggle, and I've spent hours just reviewing other people's code. How do they perform a data science project? How does their code look? Is there ways that I can implement like a quicker, a more efficient way of something based off of inspiration from them? I think that in addition to writing code, looking at other people's code and even giving suggestions to other people is very valuable. This is similar to that third point, is learn to enjoy coding. I know that debugging is not always fun, and I think especially for beginners, as I said before, there's a lot of friction in those first few weeks, in those first months, in that first year. Debugging is not always fun, but I think understanding that everybody goes through it and it's a part of the process, and flipping debugging on its head and being excited. I don't want to say being excited where there's an error or when you have to debug, but learning to really appreciate some of your errors and learning to enjoy coding. Finally, once you feel sort of confident, I know that's a big word, but once you feel confident that you have these things installed, you've taken an online Python course, might have reviewed other people's code, you watched a lot of videos and bought some books, start to produce your own projects. And this bullet point is a big one. You can really take all of the online courses you want. You can obtain certificates. You can post pictures about those certificates. There are things that come up in your Python journey that you can't prepare for. Different versions of packages, different ecosystems, different anything. There's a lot of things that are not so simple as taking an online course, and I have learned a whole lot just by debugging errors from producing my own projects. Okay, I think this is a very, very big point that eventually transition from understanding, I know what Python is, I use the word AI, machine learning, I can speak about these things, but I think producing your own project is really where there's a lot of friction. And then this is a bit later, learn a version control language. I prefer Git. So version control is, I'm not the one to explain it, but you can save versions of your code and as commits, and you can even go back to previous versions of your code. And it's really a big part of open source work and reproducible work, and possibly having other folks contribute to open source projects with you. And I think learning GitHub is a real plus. Okay, I think thank you all for staying with me this far. I think that's it for this project. That's how I came to be. Some of my journey, the best practices and advice I have for beginners. Let's go view some code. How about that? So as I said, my project is located on my GitHub account. You can save a picture of this. I know Chidi or Nathan probably have posted this link already, but we will be going over to my GitHub account for this link. So github.com/mebauer/data analysis using Python. I kind of skipped a few syntax in there, and then additional links that I would just open up in my browser. Like any programming debacle, I'm using Chrome. So I've created one example, an interactive example for you all, and it's run on my binder. So if you can all click on that, or we can go through it, okay? And we can go through it on my GitHub, okay? And then the final bullet point is inspecting some of these notebooks as static web pages. All of these things will make more sense as we view the project, but just to kind of reiterate, the first GitHub link is where the project is. The two additional links, the first one is the interactive example, and the second bullet point, view data inspection and wrangling notebook. You can view it as a static web page. Okay, should we stop there? Should I get folks on GitHub? Is everybody? I think Chidi, I can stop here and let people. I know that was a pretty quick process.
Yeah, I just wanted to add, Mark, thanks. In terms of my binder, and someone in the chat mentioned Google Colab. A lot of times when you're getting started out, maybe you haven't installed Python yet, or maybe you're at a conference like this and you don't have this set up, then those are always good web options to kind of get started with Python with a web interface. So I highly recommend those as well.
Yeah, that's a great point.
Yeah. Okay. So looks like we'll post the links as well in the chat, because I think someone requested the link for the My Binder.
Okay,
so we'll get that to you.
I can show it to you if you want. So yeah, should we pause, Chidi, or should we? I could give folks maybe 30 seconds just to take a deep breath, to get some water. Geez, it's been an hour already. Thank you all for staying with me today. And you all can see this GitHub page, right? You all can see this.
I can see it.
Okay, geez. So I think I want to make one more quick point. We won't be live coding in this session, but I'll describe some of these files for you. And as somebody said, I'll introduce you to my binder and NB Viewer, which is a way where we can view some of these notebooks on static web pages. So this is where my project's located. You can start this project here. This is called GitHub. I kind of touched upon what GitHub is, but it's a place where people can host code. There's a lot of open source code on here, and this is where I host projects. Let's go back. If you, you can start this project there. I guess let me just take you through this README file.
Hey, Mark, we actually have, I think, a really great question
Awesome.
Before you continue. So I think it was Tom brought up the issue with your My Binder file that there may be some installation or dependency issues. And as you said, we're not doing, this is not a live coding workshop, but could you make a kind of a general comment? I know you use Anaconda. And could you make a general comment about, using Anaconda and downloading packages and kind of like dependency issues that the audience may want to be aware of when they're starting out?
Geez, that's a really great point. And it's something that, a point that sometimes you don't even know is there until it it creeps up on you. So for this lecture, and for this project, I post all of my versions for these packages. So I think it would be helpful just to go through one thing. Let's view the part 3 file, plotting and data visualizations in Python. And then we will click additionally, you can view this notebook as a static web page here. Okay, sorry about this. And then I always think it's best practice if you use the watermark package and you print out packages. I think it's helpful for your audience, but it's also helpful for your own self, because you might pass files of your colleagues, coworkers, and you might execute something and something breaks and you're trying to find out, I have Pandas installed, or I have GeoPandas installed, which is a geospatial library. Why are things breaking? And I think being really cognizant of the installation process, I think installing packages is a bit outside of this scope. I install packages from the Python, repository, or I also install packages from the Anaconda platform. So I know for some beginners, that's not that intuitive, but I think installing packages is a great topic. I think it's a bit outside of this scope. What do you say? How does that sound?
Yeah, that sounds great, Mark. We don't want to get too into the weeds because we have a lot of awesome, stuff ahead. But just kind of wanted a general comment. So thank you for that.
For sure, yeah. I think, and we also had a quick point about my binder. The great thing about this binder project is that it saves all of those versions for you. So I've created a dependency file. It's called .yml file. And I'm not going to go into what is binder, what is the binder project, but if folks can open this up. So it says you can run an interactive example on my binder, blah, 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 blah. No installation is required. If you just click on this, sorry about that, I provided an example for folks that they can execute all of this code from your web browser. So let me just have a quick point about that. We can run all, and I think all of these things should be executed. But I think then again, this is just talking about versions and executing things. Okay, let me go back to the project. So as I said, this project really contains 4 different parts, and these sections include reading and writing files, data inspection, cleaning and wrangling. The third, plotting and data viz. And then the fourth one deals with geospatial data. And if you click on one of these links, it takes you here. So I describe this project. I provide you a link to this file, okay? And I also provide you let me go back. Sorry about that. Oh, what happened? Okay. And then I also provide you a static web page of this notebook. Okay. So let me go through it. I'll quickly go through some of these topics because I think we're running short. In this second bullet, I provide you the file links, a little description of the file, and you can view this file on a static web page. Okay, there we go. Okay. Third bullet point, I describe some of these data sets that I've used in this project. These are some of the most popular data sets on Open Data. Personally, I'm a very big fan of the building footprints file. There's also Map Pluto, schools, streets, neighborhoods, and boroughs. I provided links for you. So let's check out the building footprints file. And it should direct you to the Open Data page, okay? Again, bullet point 4, these are some of the open source applications that I've used in this project. Anaconda, we've already sort of touched upon that. That's how I access Jupyter notebooks, and I manage package versions, install packages. I use Jupyter notebooks up here. I used NB Viewer for static web page views of those notebooks, and then Binder. So providing a reproducible interactive notebook. Okay, and these are just some additional resources. I provided links for the NYC Open Data page, and then these are some of my other projects that are kind of included in my Open Data Python stack. This teaches you how to use Socrates API. It's okay if you don't know what that is, but it's how you efficiently query data from the Open Data platform. And then this link, analyzing 311 street flooding complaints, is just a hands-on project. I can be reached at these 3 links: Twitter, LinkedIn, GitHub. Okay, so let's view one of these notebooks. Let's do something fun. How about plotting in data viz? So we're gonna click the 3 plotting visualizations. Okay, again, I think it's very important to style your work, make notebooks beautiful, and help out the audience. I have titles here. Part 3 involves plotting in data viz. I have a table of contents. I have domain libraries, some screenshots of the data sets used. Okay, and then this is the Python code. So all of these plots, all of these figures were all generated from this code. So I don't want to go through line by line. I think if we just kind of skim some of these headers, I think that would be useful. Pluto data set, this is the data wrangling phase or step, plotting with Seaborn. Seaborn is a premier Python plotting library, and that's my preferred one. Okay, and then these are various plots that were generated from the NYC Open Data's building footprints dataset and the Pluto plain land use. I'm sorry. So these are all of the incredible plots you can do with Python. Okay, and I've presented all of this code. And let's just look at one and look at this code with each other. So essentially, this is a user guide. It's a set of tutorials that folks can look at the code, look at the Python method, look at the parameters, and look at the type of arguments that I've inserted. And it's all here. So it's quite a big file. I produced a lot of plots that I work with in my day-to-day work. There's various styles of plots. And again, all of this code is just right there. So this scatter plot that analyzes the building's ground elevation with its roof height, the Python code is really just right here. The Seaborn scatter plot method and the 2 arguments. Okay, it's a lot of interesting things. Let's view it on the DataViz gallery. So I probably should have started off here first, but I provided example of distribution plots, histograms, KDE plots, relational plots. The previous one was a scatter plot, joint grids, heat maps, categorical plots, count plots, bar plots, box plots, etc. And I also used the pandas plotting library to just plot straight from the pandas library. So we can see all of these. These are just images that I've exported from this project. Okay? Let's go back and view some of the geospatial analysis. Should I stop here, Chidi and Nathan, or should we switch gears? Do folks want to see some of how I interpret the code? What do people want?
We have some enthusiasm from the audience. They want to see a GIS example.
Okay, thank you. That's okay, perfect. So the GIS, if folks don't know, it's GIS stands for Geographic Information Systems. And for Python, I use the Python library called GeoPandas. And it's on my part 4 here, Geospatial Data Mapping. And I'm going to show you some of the gallery plots that I've produced. Okay, and so we've discussed how do we make maps, points, lines, polygons, clipping data, types of maps, choropleth maps, heat maps, hexbin, graduated symbol, proportional symbol, Voronoi maps, quadtree maps. It's all here. And we also discuss concepts like a centroid versus a representative point. A quick point, centroid is the center position of the point, but in some weird shapes, the center is really outside of the shape, if that makes sense. The representative point guarantees that the centroid is within the physical shape. Okay, we discuss set operations. That's a whole college course in itself. And then just some additional attributes. Okay, these are points, and this is just my gallery for you folks. And all of the code is here. Every single plot that I've created, it can be found here. So polygons, maps with layers, with a background, clip methods. This is defined as clipping points outside of your main figure, outside of your main shape. I won't speak too much about like types of maps. I want to focus on this project, but for folks that have a bit more familiarity with GIS, this one's for you. Choropleth maps, various styles, aesthetics, heat maps, hex bin maps, proportional symbol maps, graduated symbol maps, one-to-one dot density maps. This is a marginal histograms as well. I haven't seen this one used, but I like it. I think it's a bivariate histogram. So, or it's a single variate histogram on both sides of this figure.
Mark, quick question. As you're going through and showing these GIS maps,
Sure.
I know you spend a lot of time working with maps. I just wanted you to kind of provide context with regards to other applications you've used to map data.
Yeah, that's a really great point. I think when I was first in university, I've used Esri products, so ArcGIS, and for the past 5 years now, I've used open source platforms. So I'm a big fan of performing GIS within Python, so using the GIS package GeoPandas, but I've also produced maps and projects with QGIS, which is an open source GIS application that is free. I would say, yeah, for the past 5 years now, those are the ways that I've produced maps. Okay, these are some set operations.
Hey, Mark.
Yeah.
We have a question from Gabriella. Would you be able to scroll back up to? We have some interest in the histogram on the sides of the map.
Oh,
could you dive into that one and maybe just kind of explain, like, what is that data? How does that map work? Whichever one you prefer to use.
That's a really good question, and again, a full disclaimer. I don't see these plots a lot. I'm creating these plots with the Seaborn library. This has, of course, the map of schools in NYC. The points are in blue, and then on each side, it's a histogram of the points on this figure. So if we look at, let's take the histogram of the longitude values, that there's a lot of density over here on this side of this figure. So a lot of these schools are clustered between this longitude value. So maybe a -74 and then -73. But I think that's a really good question. I don't use this plot a lot for like production purposes or for data viz purposes. I use maybe a hex bin map or a heat map for it, but I think sometimes I'm interested to see the spatial distribution of one geometry value. Does that make sense?
We have another question for you. Thank you for that.
Yeah, sure.
Thank you for diving into that example specifically. One participant is asking, how did you export these maps? I'm assuming it's like
that's
a JPEG.
a good question. I will show you the code. So the plotting library matplotlib has a really useful method for us. We can view some of that. It's called the pyplot.savefig method. Or let me see if I can find that for you. Savefig. Okay, so it is right here. So I'm not sure if everybody's familiar with matplotlib, but all of the code in this figure needs to be in this cell, and then we use matplotlib's savefig method. And here this is where we're saving that file. So we're saving it in the figures folder called 5-1.a.png. That's something just like internal, and then we want the face color to be white. Okay, so it's right here. Saving figure.
Thank you so much, Mark. We have another great question.
Okay.
So this question is about using or producing kind of these plots with other libraries. So someone is asking, can you use these geospatial plots with Plotly and dashboards for more interactivity?
Geez, that's a good question. I believe you can. I think I'm familiar with Plotly. I tend to perform a lot of static plots, static figures, and Plotly is a, I guess, library that is really good with interactive plotting capabilities. You can, but I'm hesitant to say, Nathan, because I'm not an expert with Plotly. A lot of this work is just static PNG files.
Yeah, thank you so much, Mark. So, and I do know that Chidi just posted a link to plotly.com Python maps, and I would encourage also, we'll post another link. There's a library called Plotly Express that we've used sometimes at our agency, which also has a built-in interaction with Dash to create dashboard, which is also really cool.
Yeah, and that's a great point. I mean, keep on learning. There's a lot of great things in the Python ecosystem, and you can access these files. I would say start on this page, kind of read through this project. Apologies, this presentation was a bit quick and a bit fast, but please click on all of these things. If you're interested, read more about the MyBinder project, NB Viewer, Anaconda, and you can access all of these plots and this code through these files. Okay, Python notebook, and then it's all here. All of the code that I used to generate all of those plots, it's all here. Writing spatial data, thinking about data structures, what is a geoseries, what is a geodata frame. I also go through basic attributes and methods. Okay? I really try to really be user-friendly and present my favorite methods for these packages. Okay.
Mark, we have another great question. This is a question that I am actually quite curious about too. How long did it take for you to complete this project? It's quite extensive. It's a great resource.
Well, projects are never finished in this world. I mean, yes, I submit things and I push commits, I push files, but I'm iterating this. It took me at least a year to really go through the Pandas user guides, familiarize myself with the plotting libraries Matplotlib and Seaborn. I read through pretty much the whole user guides. I shouldn't say the whole user guides, but I really spent time looking at these methods parameters, what's included. And I think that it took a while. I mean, as you saw, the first commit was in February. So last year. Let's see this. Anyways, I don't want to. Yeah, it took me about an hour. And I think to kind of pivot from that question or to kind of provide more like clarity, when I was performing my own projects, I was tired of going back to old files and researching Stack Overflow questions. And I produced a beautiful plot, but I forgot the code. So I think with this project, if like nobody uses this, well, at least I will use this and I can go back to all of my plots, all of those visualizations. How do I read in files? I typically read in files as a CSV, but the more that you work with data, it could come in JSON, it could come in shapefile, it could come in very weird formats. It could come with like header data, metadata. And if like nobody else used this, well, at least I would use this for myself. So I refer back to this project academically in my open source work, but even in my professional career, I constantly go back to what are the best methods to inspect data. I think everybody has their own like chess moves. I can show you quickly some of my workflows. I preview the first 5 rows. I preview the last 5 rows. I preview the shape of the data set, this object's type, this data set's columns, D types, descriptive statistics, somewhere around here. And I use this for myself, but it did take me about a year and some change. So, whoa. So.
I mean, Mark, we have, I know that we're kind of wrapping up here, so maybe this will be the last question. So we have a question from Tom. Why would you use JSON versus CSV as you're describing in the reading and writing files notebook?
Oh boy, that's a great question. Oh boy. I could probably spend an hour on it. I think you bring up a really good point. I prefer CSVs. As you go further in this career, you will have data sets that are not in CSV files. For instance, sometimes I preview a data set's metadata, and usually the author has nested data dictionaries within that file, and I think that's really like a real world example of where I use JSON files, that it's not like a rows column data set, but it has a lot of nested dictionaries. And I can show you one, I guess, quick example. Where's the JSON example? And then we'll kind of like wrap up. So I'm using the URL lib package. We are previewing this object's keys. It's a dictionary. Then we're previewing the length of this object. We are previewing the first row, etc. So I think that there are ways that I find JSON files. And I think as an analyst using Python, you will come across JSON, but yeah, if you can use CSVs, that's my method for data files. So, geez, thanks everybody for staying with me for this hour. Let me stop sharing. Stop share. And I think that's it. Thank you all. This is a big honor. We kept 81 people. Chidi, Nathan, Gabby, is there any final words or anything you would like to say? Or
no, that was excellent, Mark. Really thank you for doing this. Just if you can reiterate the best way to contact you if people have questions. I did mention in the chat that we're going to update the GitHub once we figure out how to distribute the video file, like what platform we'll be using. But if you could just reiterate how best to contact you, that'd be great.
Yeah, sure. On my GitHub profile on this project, on the bottom, I'm on Twitter. I'm on LinkedIn. Yeah, but I would probably prefer LinkedIn, Twitter. Yeah, either one of those would be fine. And please reach out, say hello. If this project helped you getting started, please send me a quick note because I'll do more of these projects. But yeah, go to my GitHub and it's all there.
Well, thank you so much, everyone. And thank you, Mark. It's been a wonderful presentation and I hope everyone has a great day.
Thanks, you as well. Thank you.